Claude Certified Architect is Anthropic's first certification, and I am here today to help you pass it with flying colors. In this video, I will give you the foundational understanding of how to prepare for this certificate, where the main pitfalls are that people fall into during the exam, and how you can guarantee your readiness by following a few basic rules. Once you start the exam, you will see 60 multiple-choice, scenario-based questions, and you need at least 75% of them correct to pass. For those questions, Anthropic has written 6 production scenarios. The system picks 4 at random and serves them to you, and every one of your 60 questions is anchored to one of those 4. Every question drops you into a working system, often one that is already breaking, and asks which architectural decision is right given the specific circumstances. To cover all 60, you have about 2 minutes per question to stay on track. Let's go a bit deeper into the specific domains. Before we go domain by domain, lock in what Claude actually is as a system, because the test assumes you already know. At the bottom of every Anthropic product, there is one thing: a language model behind a single HTTP endpoint at api.anthropic.com/v1/messages. You send it a list of messages, you get back a response. The model has no memory between calls, it does not run loops, and it does not execute code. That endpoint plus those 3 facts is the entire engine. Everything else is a layer of discipline wrapped around that endpoint. And there are 4 of them you have to recognize by name, because each one is what 1 or 2 of the domains tests directly. The Claude API is the raw HTTP endpoint, plus the official Python and TypeScript SDKs that wrap it. The Agent SDK is the framework Anthropic ships on top of the API that runs the agent loop, spawns subagents, and provides built-in tools so you do not rebuild them by hand. Claude Code is the terminal agent that boots Claude inside your repository and gives it file system access through read, write, edit, bash, and grep. And MCP, the Model Context Protocol, is the open standard for how external tools and data sources expose themselves to any compliant model, so the same payment processor or internal wiki or database plugin works across all 4 surfaces without rewriting glue code. Now the map. Domain 1 and parts of Domain 3 live on the API and the Agent SDK. Domain 2 is Claude Code. Domain 4 is MCP. Domain 5 sits across all of them, because reliability is a property of the whole system. Hold that picture in your head, and every scenario the exam throws at you is just a question about which surface owns the broken behavior. Domain 1, Agentic Architecture and Orchestration, the heaviest domain at 27%. Claude is stateless. It does not remember the last call you made, it does not run a loop on Anthropic's side, and it does not execute tools by itself. Every time you want Claude to do multi-step work, your code is the loop. When you call the messages.create endpoint and pass Claude a list of tools it is allowed to use, the response comes back with a field called stop reason. 2 values on that field decide what your code does next. If stop reason equals end turn, Claude is done thinking, and the response text is the final answer. If stop reason equals tool use, Claude has paused mid-thought and is asking your code to run a function on its behalf. You pull the function name and arguments off the response, you execute that function locally, you append the result back to the conversation history as a tool result message, and you call messages.create again with the updated history. Claude picks up where it left off and either calls another tool or finishes. That cycle, call, inspect, execute, append, call, is the entire agent. Drop the inspect step, and the agent goes silent after 1 tool call. Drop the append step, and the model loses the result and tries the same tool a second time. At least 4 of your 60 questions hand you a code snippet where one of those steps is missing, and the answer always names the broken step directly. The second half of this domain is what happens when a single Claude is not enough. A top-level Claude, the coordinator, breaks a job into pieces and spawns smaller scoped Claudes, called subagents, to handle each one. The coordinator spawns them through a built-in function in the Agent SDK called the task tool. The whole reason for the pattern is context budget. A coordinator that has to read 10 files, run 5 searches, and draft a summary will fill its own context window long before it finishes. By spawning a subagent for each file read, the coordinator gets back only the subagent's compact summary and keeps its own context lean. 2 decomposition styles to know. Sequential decomposition means the coordinator finishes subagent 1 before spawning subagent 2, and it is the right call when each step depends on the previous step's output. Adaptive decomposition means the coordinator picks the next subagent based on what came back, and it is the right call for open-ended work, like investigating a competitor's pricing strategy. And when one subagent fails halfway through, the right recovery is almost always a targeted retry of just the failed one, because the successful subagents may have already written rows to a database or fired off emails, and you do not want to fire those a second time. Domain 2, Claude Code configuration and workflows, 20%. Claude Code is the terminal agent that runs Claude directly inside your repository, and by default, every new session starts with 0 memory of your project. CLAUDE.md is the file that fixes that. When Claude Code boots, it walks up the directory tree from your current folder, finds every file along the way named Claude.md, and stitches them into the session's system prompt. The hierarchy sits at 3 levels, and the exam will absolutely test you on putting a rule in the wrong one. The user-level file lives at ~.claude/claude.md. It applies to every project on your laptop and never goes into version control, so anything there is for you alone. The project-level file sits at the repo root, gets committed to Git, and ships with every clone, which is where team-wide conventions go, like everyone uses bun instead of npm. And the directory-level file sits inside a subpackage, like packages/API/Claude.md, for rules that should only apply when Claude is touching code in that specific folder. The exam loves to ask where the rule that everyone must run lint before commit should live. The answer is the project file at the repo root. Putting it in your user file means your teammate's clone never sees it. Custom slash commands are the second piece. A slash command is a reusable prompt you invoke by typing a /, like /review. You define one by dropping a markdown file into .claude/commands. The body of that file is the prompt that gets injected when the command runs. The YAML front matter at the top is where you constrain how it behaves. The Allowed Tools field restricts which Claude Code tools the command can call. So a review command can be locked to read-only tools, like read and grep, with no write or bash access. The argument hint field is the placeholder shown in the picker, so it documents what argument the command expects. And then there is headless CI/CD. Claude Code takes a flag, -p, that runs it non-interactively with a prompt baked in. Combined with a structured output schema, this lets your pipeline ask Claude to review a pull request and return a JSON object with named violation categories. The architectural lesson the exam keeps coming back to is that your pipeline should fail only on categories the schema can name explicitly, like security violation or breaking API change. A pipeline that fails whenever Claude expresses vague concern produces noise the team tunes out within a week. And a Claude review the team tunes out is worse than no review at all. Domain 3, prompt engineering and structured output, also 20%. Vague instructions are ambiguous instructions. When you tell Claude to review this PR carefully, the model has no shared definition of the word careful, so it flags anything in the diff that pattern matches to caution, which is essentially everything, which is why your inbox fills with false positives the same afternoon. The fix is to swap every adjective in the prompt for a list of categorical, mechanically checkable rules. Instead of review carefully, you write Flag if any function exceeds 40 lines. Flag if any new third-party dependency is added. Flag if a public type signature is removed. Each rule has a yes or no answer the model can compute by reading the diff, and the false positive rate drops sharply. Pillar 2 of this domain is structured output. Your downstream code expects JSON, and the model produces text. The naive way is to write return JSON in the prompt, and hope. And Claude will comply. Most of the time. Right up until the morning it prepends a friendly, "Sure, here is your JSON." And your parser explodes in production at 3 in the afternoon. The reliable way is to declare your output shape as a tool. You define a tool in the Anthropic SDK whose input_schema field describes the JSON shape you want. You pass it in the tools array, and you set tool choice to force the model to call that one tool. Instead of free text, the model returns a tool use block whose input field contains your schema-compliant JSON. This works dramatically better because Anthropic fine-tuned Claude hard against tool schemas, so its compliance rate on tool use inputs sits much higher than on free text format instructions. Even with tool use, schemas drift sometimes, and the pattern for handling that is a validation and retry loop. On every response, you run the returned JSON through your schema validator. When validation fails, you do not retry blindly. You take the validator's error message, append it to the conversation as a user turn that says, "Your previous response failed validation with this specific error. Please return a corrected response." And you call the model again. The model now has its own previous output and the exact field that broke in context. And the correction rate on the second attempt sits above 90% in practice. The last beat is batch processing. The Message Batches API lets you submit thousands of independent prompts and pick up the results within 24 hours at 50% of the per token cost of real-time calls. The exam hands you a scenario about classifying 100,000 documents overnight and asks whether to loop or batch. Batches are the right call whenever the work is offline, latency is measured in hours, and the prompts are independent, so order does not matter. Domain 4. Tool design and MCP integration. 18%. MCP stands for Model Context Protocol, an open standard Anthropic published for how external tools and data sources expose themselves to a language model. Before MCP, every tool integration was a one-off wrapper specific to one model. With MCP, the model speaks a single protocol, and any compliant server, a database, a wiki, a payment processor, your internal API, plugs in and the model can call it without changes to the model code. 3 things to learn deeply. First, tool descriptions decide whether the model picks the right tool. At decision time, the only thing the model sees is each tool's name, its description, and its input schema. If you ship 3 tools called getUser, lookupUser, and findCustomer, all described as returns user information, the model picks essentially at random, and the exam scores that as a schema defect. The tool definitions have to solve. The fix is to write tool descriptions the way you write API docs. 1 sentence on what the tool does. 1 sentence on when to use this one over its siblings, so the model has a disambiguation rule. 1 example invocation with realistic arguments, and a list of error conditions the tool can return. Second, structured error responses. When a tool fails, the right shape is a JSON object the model can branch on, an isError Boolean, so it knows it hit an error path, a category string, like rate limited or not found, so it can pick a recovery branch by name, a retryable Boolean, so it knows whether to retry, and when applicable, a retry after MS integer, so it knows how long to wait. With that shape, the model writes a clean recovery plan in 1 step.
Without it, the model gets a raw exception string and either gives up or starts an infinite retry loop you find later in the logs at 3 in the morning.
Third, transport selection. MCP supports 2 transports. The STDO transport runs the server in the same process tree as the client over standard input and output. 0 network latency, 0 authentication overhead, and it is the default whenever the server can live on the same machine. The SSE transport, server sent events, runs the server on a different host, and the client connects over HTTP, which adds network round trips and forces you to design an authentication scheme. The rule the exam keeps testing is direct. Pick STDI whenever the server can live on the same machine as the client. Pick SSE only when the server has to live somewhere else, like a centralized database connector serving multiple users from a shared host. Domain 5. Context management and reliability. 15%. Concept 1. The lost in the middle effect. This is an empirical finding from research on long context language models that is held across every model family, including Claude. When you stuff a long conversation or document into a context window, the model pays the most attention to whatever sits at the very start and the very end, and almost none to whatever sits in the middle. The exam exploits this directly. A customer support agent has been chatting for 40 turns and is suddenly forgetting that the account number was given in turn 3. The right fix is to identify the durable facts, things like account numbers, order IDs, and refund amounts. Copy them into a small, structured block of text, often called a case block, and re-anchor that block at the very end of the context on every turn, so the model's attention always lands on it. The tempting move is to ask the model to summarize the whole conversation, and that is exactly the distractor the exam puts in front of you, because summarization compresses with lossy heuristics and silently drops numbers and IDs. Concept 2. Prompt caching. Every input token you send costs money, and if you send the same 50,000 token system prompt on every call, you pay full price for it every time. Prompt caching fixes that. You add a cache control breakpoint at the end of any prompt section you want to reuse, like your system prompt or your few shot examples, and Anthropic caches the model's internal state at that point for the next 5 minutes. Calls that reuse the exact same prefix pay roughly 1/10 of the input price on the cached portion. The architectural lesson is what is worth caching. The system prompt is worth caching because it is identical on every call. Few-shot examples are worth caching for the same reason. The user turn at the end is not worth caching because every user types something different, and caching it just burns the budget on entries that never hit again. Concept 3. Escalation. Reliable agents have to know when they do not know. The exam treats an agent that confidently answers a question it should have escalated as a worse failure than an agent that escalates a little too eagerly. The first ships bad answers to customers. The second just costs you a few extra human review tickets, and that is a trade you take all day. The pattern to recognize is an explicit confidence check at the end of the agent's reasoning, with 2 triggers. Either the model's stated confidence falls below a defined threshold, or the model detects ambiguity it cannot resolve from the conversation history. Either trigger hands the conversation off to a human, along with a structured summary of what the agent knew, what it tried, and where it got stuck. Anthropic has published 6 production scenarios. The proctor picks 4 at random and serves them to you. You study all 6 because you do not get to choose, and you also want to know which domains tend to attach to which scenario, because that is what makes the question pool predictable. The customer support agent scenario is where most of the agentic architecture questions land. Escalation, retries, and partial failure handling get tested there hardest. Claude Code team integration is where the CLAUDE.md hierarchy and / commands get tested. The multi-agent research pipeline is where coordinator and sub-agent orchestration shows up, and it is the most likely scenario to throw a context overflow question at you. Developer Productivity Tools sits on the built-in read, write, edit, bash, grep, and glob tools, and on when to reach for an MCP server instead of writing your own. Claude Code in CI/CD covers headless invocation, structured output, and false positive minimization. Structured data extraction is the JSON schema and message batches scenario. 2 of those 6 will not show up on your exam. You do not know which 2. 4 weeks, and every resource in this plan already lives. Each week runs the same rhythm. You read the domain guide for the theory. You build the matching graded project for the reps. And you run the 500-card deck for 15 minutes every day to keep recall sharp. The 6 practice exams are your weekly checkpoints, and the domain weights decide where your hours go. Week 1 is Agentic architecture, the heaviest domain at 27%, so it earns the most time. Read the Agentic architecture guide, then build 2 of the graded projects, the agent loop with safe termination and the hub and spoke orchestrator, where you force a subagent to fail and write the recovery path yourself. Close the week with Practice Exam 1 as your baseline, and do not flinch at the score, because that number exists only to show you what the next 3 weeks have to fix. Week 2 is the 40% block, Claude Code configuration and prompt engineering side by side. Read both domain guides and the cheat sheet, then build the Claude Code skill and command project and the prompt and eval project, where you turn one vague prompt into a numbered rule prompt and prove the gain with a real evaluation. Run practice exams 2 and 3 as your checkpoints, since both lean straight into these 2 domains. Week 3 is tool design and the model context protocol. Read the MCP architecture guide, then build the full MCP server project end to end, with real tools, complete descriptions, structured errors, and secrets pulled from environment variables, and Claude connected as the client. Finish with Practice Exam 5, the anti-pattern set, because most tool questions are really checking whether you can spot the broken contract. Week 4 is context management and your dress rehearsal. Build the long context project with crash recovery and the compaction project, and confirm a single cache control breakpoint drops the cost on the cached portion to roughly 1/10. Then sit practice exams 4 and 6 back to back under the full 2-hour timer, because that timer is the part most candidates skip in practice and lose 10 points to on exam day. 5 distractor patterns to recognize on site, because every one of them shows up more than once across the question pool, so the viewer feels these traps are unavoidable. The vague adjective trap is any option that sticks careful or thorough into a prompt to fix a false positive problem. The graded answer uses a numbered list of categorical rules the model can check one at a time. The summarization trap is any option that compresses a long conversation in a scenario where it carries IDs and amounts. The graded answer extracts the durable facts into a case block at the end of the window. The blanket retry trap is any option that reruns every subagent after one fails when the others already executed side effects. The graded answer retries only the failed one. The user-Claude.md trap is any option that puts team-shared configuration in the user-level file in your home directory, which never reaches version control. The graded answer puts shared rules in the project file at the repo root. And the SSE on localhost trap is any option that picks SSE transport for a server running on the same machine as its client. The graded answer picks stdio. You are going to walk in there and the exam is going to be fair because it rewards exactly what you have actually built. So go build it. Spend the 4 weeks the plan lays out. Sit the 2 timed mocks even when they feel pointless on a Sunday afternoon. And on exam day, show up to the proctored room a little early. Take a breath and remember that every scenario on the screen is something you already debugged in your own terminal. By the time you hit submit on question 60, the result is already decided by the 4 weeks you put in. Go pass it.